VS series, measurements and dimensions.
Connect to the Measurements and Dimensions simulator, and you will see the test images that will be used to give you an overview of the Measurements and Dimensions category. For this example, we're not going to do any position adjustment in the positioning category, but in the real application, set up any kind of position adjustment that you need for the application. The Measurements and Dimensions category can be found in the Inspection section of the main task. If you click on Measurements and Dimensions, you'll see the available categories. This category of tools just makes it really easy to do any kind of measurements and dimensions on the target using the Key and Space toolset. So for example, you could do distances, distance between points, a point in a circle, distance between lines, a line in a circle, or circle distance. So this is the distance category. Then we have the width category, the distance between edges, profile width, which is a min and max distance between edge widths, pitches, and point distances. So various widths that you can do. In the line angle category, you can do line detection, line passing 2 points, the bisection of lines, angled forms between two lines are various things you can do. Under the circle section, you can detect circles. So based on edge points, you can calculate the circle radius and position. You can do intersection points, where a line and vertical line intersect, where two lines intersect, the center of a quadrangle, or the midpoint between 2 points. All right, and you can also detect points. So points can be detected with patterns. So the pattern positions, edge positions, min and max position of an edge using the profile position tool, blob or grayscale blob. So you can detect points. And then once you detect points, lines, etc., you can do all kinds of measurements between them by easily clicking. So this video will go over some examples of how you can do this. So the first thing we're going to do is detect the two circles up here on this top part here. So we'll detect this inner circle and this outer circle. So go to the circle section here and we'll do circle detection. And we'll start with image number 1 in the film strip, but you could use any of these images as needed, but we're going to start with image 1. So add a circle detection tool, and as a default, it will use a ring type region. So all you got to do is click 3 points near the circle that you want to detect. All right, so let's start with this outer circle here. So I'm just going to click 3 points along this circle, and you can see it adds the tool and it detects the circle. The base tool for this is the profile position tool set for ring, and it's detecting the best fit circle, what you can see in green. So you can adjust the settings as needed, but I'm going to leave everything default. But you can refer to the profile position tool for more details on how this tool actually operates. But the bottom line is it will create the best fit circle and the detected circle. So you could see it's got the detected circle X and Y, radius, and diameter. And you can put tolerances directly on that, or you can use that the center point in another calculation here, which is what we're going to do. So I'm not going to put any limits on this, but you could put limits on that as needed. So now I'm going to repeat that same thing for the inner circle. So just add another circle detection tool, and then click 3 points on that inner circle. So in this case, we're going to click 3 points on this inner circle, and it will calculate that inner circle best fit circle. So again, on the judgment tab, you can see here's the detected center XY of the circle and the detected circle radius and diameter. Right now we're in pixel units, but you can use scaling, of course, to scale the units, but we're going to just work with pixel units for this example. All right, so now that we have these two circles, we can now do a distance between those two circles, centers, and see if they're concentric, see if they're in line with each other. So that's what we'll do next. So go to the Add Tools again. Again, measurements and dimensions category. So we're going to go on to the distance category this time, and we're going to do a circles distance. So distance between circle centers. So now that we already have our circles detected, it's as simple as clicking on them. So you'll see this right now. So add the circle distance tool, and then you can specify circle 1 and circle 2. So you can see if we hover over this, it'll highlight the circles that you're detecting. So for the first circle, I'll click on that first inner circle and then specify the second circle. So I will click on the second circle. And what it will do is calculate the distance between those center points. All right, and then we can go to the Judgments tab here. So here's the distance between the center points. It even breaks it down to separate X distance and Y distance as needed. So if we put a upper tolerance on this, let's just use 2 for this example. Again, we're in pixel units. So if it goes above 2, we want it to fail, the distance between those circles. So if they get out of concentricity. So if I click on image 2, you can see there is a small deviation in the circle there. All right, so we are failing the tool because the distance jumped to 9 pixels here. So you can see the circles are offset. So this could be used, again, to see if 2 circles are centered on top of each other, basically, and you can pass and fill accordingly. Next, what we'll do is we'll detect the center points of these 3 holes down here so we can do some measurements between them. So for that, we will go to the, again, measurements and dimensions category and point detection. So you can do various ways you get points, as I mentioned earlier, pattern searches, edge positions, things like that. We're going to use the blob tool. So the blob tool will find the center of gravity of the blobs that are on the screen, so we can detect that. So by the way, as you're going through these tools or adding any of these tools, when you see this little question mark help icon, you can click on that and it will open to the details of that tool. So in this example, it's showing how the blob tool operates. So if you want more details on how these tools work, just click that little help icon. So we're going to click the blob tool and add it, and then draw our inspection region where these holes are. So if I draw it in here, I'm just going to draw it like so, and click OK. All right, and then blob will detect the white blobs as the default. So we don't need any angle range for these blobs. So I'm just going to turn that off. I'll set this to none. And I'll leave everything else default. But you can refer to the blob tool tutorial video for more details on how the blob tool works. But we're not going to put any judgment limits on this right now. We're just going to use these points in other calculations. Okay, so I'm going to go back to image 1 for now. And now what we're going to do is we'll do the points distance tool to get the distance between these holes. So we'll do 2 different tools, one for this distance and one for this. So now that we have these points, we can easily add that tool. So from the measurements dimensions category, let's go to the distance category, and we'll do points distance. So the distance between 2 points. So if I click this little help icon, just to show you what that looks like, it's going to calculate the distance between 2 selected points quite easily here. So go ahead and add that. And then what we'll do is we'll do the distance between these 2 holes first, and then we'll do another one that will be the distance between those holes. All right, so you can see specify point 1. So we'll specify this point, just click on it as point 1, and then we'll just specify this hole to the right as the second point, and it will calculate that distance as you can see here. So you can see the line that's drawn graphically. If I go to judgments, you can see you can put our limits. Again, we're still in pixel units, which is fine. That's what we're going to do for this example, but again, it can be scaled as needed. But you can see it gives you the distance and also separately the X and Y distance if you want to see that separately. So for this example, let's go ahead and put an upper limit and lower limit on this. So you can adjust this as needed, but I'm just going to give it like maybe a plus or minus 3 pixels range here for now. Always, of course, can be adjusted as needed. But if that distance falls outside that range, the tool will fail. So if I go to image number 3, I think it is, image number 3, you can see the distance, this hole has moved over. So the distance shot up and it turned red and failed. So we're failing it if that distance is too far away. All right, so what we can do now is repeat that for these 2 holes. So I'm going to go ahead and add another points distance tool. And then this time we'll use these 2 points as our detection points. So I'll click this first hole and then this second point. So you see now this one calculating that distance between these 2 holes, which is a little bit bigger than this distance. So if I go to judgments here, I can go ahead and set myself an upper and lower limit here as well. So again, I'm going to use about 3 pixels in each direction. for the detection, and then it will pass and fail accordingly. All right, so you can see again, if that distance gets too small or too big, it will fail. All right, so points distance can be very easily set up to measure distances between detected points. Once you have the points, you just click them on the screen and it will automatically do the distance for you. So the next thing we're going to do in this example is we'll get the detected line for all four sides. So we'll detect the best fit line on the top, right, bottom, and left. All right, so let's add a line detection tool. So go to the line/angle category here, and you could do line detection. So you could calculate a line from a profile of edges or the line passing 2 points. So either way, you can calculate lines. So I'm going to do line detection, which will profile the edge surface and calculate the best fit line, as you can see here. The raw base tool for this is the profile position tool, calculating the best fit line. So we'll go ahead and add this. But if you add it from this category, it makes it really easy, because all you need to do, as you're going to see here, is click 2 points along the line that you want. So I just got to click once, twice, and then it draws the measurement region for me and calculates all the edge points and calculates the best fit line. But again, the base tool for this is the profile position tool, calculating the best fit line. So I'm going to leave everything default here, but you can adjust as needed. And again, if I go to the judgment tab, you can see is giving us the detected line angle there. But we can now use this line in other calculations. All right, so I'm going to repeat this for all four sides now in the next step. Okay, so we're going to add more line detection tools, but real quick first on the general tab, we're starting to get a lot of tools here, so it might be easy or more clear if we start naming these tools. So I'm going to do, I'm just going to rename this tool line top, just so we can keep track of what's going on here. So you can, in the general tab for all these tools, you can give it tool names as you go along, just to kind of keep track of things. So that's our top line. So now we're going to repeat that for the right side here. So let's add another line detection tool, same tool. And again, we're going to click 2 points along the profile that we're looking for. So in this case, I'm going to go on the right side. So click, click, and now we have our right side line. So I'm going to go to the general tab here and just rename it here, just so we know what's going on. So that's the right side. And now I'll add another one for the bottom. Just repeat these steps. You can see how easy this is. It's just a bunch of point and click. Pretty easy to do. So again, I'm going to click 2 points along the bottom line. So now we have our line on the bottom. And then, oops, sorry, let me fix that. There we go, bottom. And then I'll add one more for the left side. And now we'll have all four lines, and we could do other dimensional measurements from that point, from all these lines. All right, so once I get my points here, click, click. All right, and this is our left side. So let me just change the name to left. All right, and then we have our four lines detected on all four sides, and we could do other measurements on them. What I'll do now is I'll show an example of getting the distance between a circle center and a line. So we'll calculate how far this circular part up here is from the top line of this target here. So I'm going to go ahead and add, and then from the distance category, we're going to do line circle distance. And again, if you want to, you can click this little help icon. Let me just show you what this will do. It's going to calculate the distance between a line that's perpendicular to the selected line and the circle center. So again, line circle distance, let's add that. And then we can select our points, because we've already detected our line and we've already detected our circle. So all we have to do is point, and click. So the first step is to specify the line. So let's specify this top line. Just click on it, and now you specify the circle. So I'm going to choose this circle here, and you can see it calculates that distance here, and we can put a judgment on it. So what I'll do is I'll put a limit on this. Again, it's just pixel units, so we'll just put maybe plus or minus 2 pixels about for our limit. And if it gets too close or too far, we can have it fail. Now, if you go to image number 5 here, you can see the circle is a little offset from where it normally should be, and the tool fails. All right, so as long as these circle detect tools are still detecting the circle properly, you'll calculate this distance. Now, if you need to use position adjustment, if this moves around too much, then you could use some, you don't want to use some position adjustment first to position adjust the tools as needed, like that circle detect tool. But in this case, we could detect if it's just offset by a little bit here, so you can see. All right, so distance between the circle center and line just by pointing and clicking. Next, we'll show you a distance, measurement distance from a line to a point this time. So we'll do the distance between this detected point on this right hole to the right side line, and we'll see if how far that is. So for an example, so again, from the distance section of the category here, let's do point to line distance. So this will do the same kind of thing, but the detected point to the line instead of the circle in this case. So let's go ahead and add this point line distance tool. And then for the point, we'll use this circle on the right, and then we'll use the right side line. So for the specified point, we'll specify this hole right here, and then we'll choose our right side line. And again, it calculates that distance. And then we can put our judgment limits on that. So I'm going to go to the judgment tab here. And just like I've been doing on the previous examples, I'll give it like a plus or minus 2 pixel tolerance for now. Again, you would adjust it according to the application, of course. But let's just give it like plus or minus 2 pixels here. And then we can see if it fails. If you go to the image number 4 here, you can see it does fail because the hole gets too close to the edge. So you can do a lot of different distance measurements to accomplish your application. Next, we'll show you an example of a line distance. So distance between lines. So it's called line distance. Just to show you what I mean by that, let's click the help file here. I'll show you what it's doing. So what it's going to do is it's going to specify 2 lines, line 1 and 2, and it's going to measure the length of the perpendicular line drawn from the midpoint of line 1 downward to line 2. So that's what this tool will do. So we'll go ahead and add this line distance, and we'll just pick the top and bottom line to show you just an example of what that would do. All right, so again, it's just as simple as pointing and clicking once you have the line. So we already detected our lines earlier. So all we need to do is click the top line, the bottom line, and then it calculates that distance. All right, and you would put a judgment accordingly. I don't really have a good and bad for this one, so we're just going to leave the judgment open, but I wanted to show an example of a line's distance. Another thing you can do with lines is you can get the bisection line angle of 2 lines. So let's show that next here. So let's go ahead and add, and it's going to be under the line angle section here. It's the bisection of 2 lines. All right, so again, what it'll do is it'll just give you the bisection of the 2 selected lines. All right, so let's go ahead and add that. And then what we'll do is we'll do the bisection of the top line and the right side line. All right, so for line 1, I'm going to specify the top. And then for line 2, I'll specify the right side. And you can see it calculates that bisector line angle. All right, so if I go to the results down here, you can see it tells you the angle of the line detected. All right, so if I go to judgment, we can put a judgment on that bisector angle if we want. Back on detection here, you can also do this line, median 1 or median 2. So median 1 would be this bisector here. If you want the other one, just click median 2, and then again, put your judgments accordingly. For this example, I'm going to leave it on median 1. We can also simply do the angle between two lines. So for example here, if you wanted to get the angle between the left side and top side and make sure that's nice and square, we can do an angle between two lines. So from the add tools, again, this is under the same line angle category, the angle formed between two lines. So I'm going to add that. And then what we'll do is we'll select the left side line and the top line, just to give an example here. So here's the left and then top. And then what we'll do, you can see it's calculating that angle between those two lines there. And you can see it's about 90 degrees, which is what we expect. So what we can do, again, is judgment and put a judgment on that if we want. We can make sure it's not too out of whack. So maybe it's plus or minus, whatever the tolerance is. Let's say it's plus or minus 2 degrees. We'll do 92 for the upper, maybe 88 for the lower, but set that accordingly. You can also change the measurement target as needed to angle 2 or the 360 angle 1, angle 2, but so you have a variety of measurement targets you can select, but we're going to leave it on angle 1. Just check it to see if that's square. And I can repeat that on the 4 corners as needed, but we won't do that for right now in this exercise, but you could repeat that as needed for the other 3 corners as well. You can also easily calculate the intersection point of two lines here. So if you want to detect this XY position, that can also be done with this measurements and dimensions category. All right, so let's go ahead and add another tool. And this is going to be under the intersection/center section. All right, and you can see you have two lines intersect. All right, so we're going to do two lines intersect, that point where two lines cross each other. So add this, and same as everything else, we're going to specify our two lines that we already have detected here. So we're going to detect, here's my left line, and then my top line, and it's going to detect where the point in space where those two lines cross. All right, and if we want to do that for the other corners, we of course do. So let's do it. Let's repeat that for the bottom right corner here, and then let's say you want to do the distance then between those 2 points. So let's go ahead and add another two lines intersect. Same tool, and then we'll do the intersection down here on the lower right. All right, so I'll choose the bottom line, and then the right line, and you can see we are now detecting that cross point. And of course, you can put judgments on that if you need to, if you're going to pass and fail it based on position. But what we'll do next is we'll do a distance between those 2 points. Say you want to calculate the squareness or what have you of this part, and we want to calculate the distance, the diagonal distance between those 2 points we just detected. All right, so because once you have the points and lines detected, you can add additional measurements on top of them. So let's go ahead and add a distance between 2 points distance, and then we can click those 2 points that we just calculated, the 2 intersection points. So here's point 1, point 2, and it calculates that distance. And then we can put judgments on that accordingly. I'm just going to leave no judgment on it now, but you would set your judgments accordingly. Another handy function you could do with this measurements and dimensions category is the center of a quadrangle. So in other words, a shape formed by 4 lines, you can calculate the center of that. So let's show a quick example of that. So if you go from the Add Tools menu, Measurements and Dimensions, let's go to the intersection/center section, and it's center of a quadrangle. So again, let me just click the help file here just to show you visually what we're going to be doing. Is you just specify 4 lines. They could be, as long as they enclose or touch each other, it'll calculate the center of that quadrangle here. So let's go ahead and do that. So add this tool, and what we'll do is I'll show you. We'll use the left side line, the top line, and then the bisector line, and then the bottom line, and we'll calculate the center of that. So in other words, we'll use this shape right here. So I'll click, it says specify the upper line, so we'll click upper, specify the right, we'll do right, lower, lower, and then of course the left. So you can see it'll use this shape and calculate the center of that quadrangle. And again, you can put a tolerance on the X and Y. So pretty handy little function here just by simply clicking on the lines that you have already detected, and it does all the math for you. Next, let's say you want to do a min and max width of the entire part itself. So the min and max width across this area here. So we can easily do that with the width section here and the profile width. So this is just the profile width tool, but it happens to be very handy to calculate the min and max width over an area here. So I'm going to go ahead and add this to the task here, and then just simply draw your rectangle. Now, when you're using any of the edge tools, this arrow here is the direction of scan. So I'm just going to flip this, rotate this 90 degrees, since I want to go from top to bottom. And then I'm just going to draw my box here. Let me fix that rotation angle a little bit. But you just draw it across the area here. And then I'm scanning from top to bottom for edges. And what it's going to do is going to break the region into many smaller pieces and give me a min and max width. Now, in this example here, it doesn't have enough segments, so we need to just raise the amount of segments. It's 100 as a default. I'm just going to change it to 300. And that should cover the whole area, as you can see here. And then in the results here, or in the judgments, you get the number of detected segments, which is segments that detected valid width, and then you got your min and max width. So again, this is pixel units. So we can put a tolerance on that. So if any of these individual measurements went out of tolerance, the tool will fail. So again, if you want more details on this, it's just the profile width tool. So you can refer to the tool tutorial video on that one. So for one more example of this category is, let's say you want to detect the radius of this edge here. So it's a rounded corner. So you want to detect that radius and perhaps put a tolerance on it, etc. All right, so that's basically just a detect circle, but we don't have a full circle. So as long as you have enough points along that profile, it can still calculate the best fit circle. So let's go ahead and add a circle detect tool. So again, it's the same tool we did earlier, circle detect. But in this case, we're going to set it to an arc instead of a ring, you'll see. So let's go ahead and add this. It defaults to a circle ring type inspection, but we can change it to arc. So if you don't have the full circle, you only have a piece of the circle, you can use an arc. So I'm going to click 3 points along this arc. So 1, 2, 3. And then as long as it has enough edge detection points, which you can see here, it calculates that best fit circle, just as long as it has enough points. So you can see it profiled this circle here, this edge. It has enough points here, so it calculates from that point the best fit circle. And again, we could go to judgment. You can see here's the circle center X, center Y, and the detected radius and diameter. Again, we're in pixel units right now, so it's all in pixel units, but we can use that, put tolerances on that. We can also use this point now in other dimensions if we want. All right, so I can repeat this for the other corners too. So let's go ahead and just do it for the bottom right, just for another example here. So again, I'm going to add another circle detection. And this time we'll do it on the bottom right corner. Again, we'll set it to arc instead of ring, because we only have a partial circle. And I'll just click 3 points along this bottom arc there, and then detect that circle. So quite easy. And then you could put, like I said, you could put limits on that. We could repeat that for the other 4 corners as well. And of course, you could use those points now in other dimensional measurements if you'd like. So summarize this tool, measurements dimensions category, is it just makes it really easy to do all kinds of measurements and dimensions between lines, points, circles, etc. So it uses the base Kias toolset, of course, to get the data, but it takes a lot of the work out of it. You don't have to try to do any calculations yourself in the dashboard or anything. You can just do it right in the tool itself. So it makes it really easy to do point and click method to perform a variety of measurements and distances.